what do you notice about this one? It's a difference of 2 squares, so I'm going to go 3x squared minus 4, 3x squared plus 4. And I can't factor anything any further, right? So I just leave it, and I'm going to set each piece to 0. 3x squared minus 4 equals 0. 3x squared plus 4 equals 0. And I'm going to solve each one. 4 4/3. Now, here's the tricky part, because whenever I take the square root here, I end up with plus or minus, the square root of 4 is 2, but 3 doesn't have a perfect square. So I have to get that square root out of the bottom, right? And to do that, I just multiply the top and the bottom by square root. So at 2 root 3 over 3. There's 2 of my answers. And then for the other one, same deal? Yes? Yes.
All right, and second question. I know how you got 3 and 4, but why is it not like 1 with 3 on the outside?
All right, say that again.
Like, why is it 3 on the outside? Like, why is it not 3?
Which step are you looking at?
First step. Like, see how 1 is? Why didn't we do the same thing for 2?
Because you can't take a 3 out of 16.
Oh, okay.
It didn't have a GCF there. It did not have a GCF to start with on this one. So it factored. All right, that was 2. And then you say which other one? 6? 1? Number 1, 12x cubed minus 3x squared. This one's a little bit different because this one does have a GCF that I can take out of both of them. What's the GCF here? 3x squared. When I take that out, what's left? It equals 0. Now, everybody goes to 0, right? 3x squared equals 0. 4x minus 1 equals 0. And I'm going to solve each of these separately. For this one, x equals 0, but it has a multiplicity of 2 because of that x squared there, even though it's the same thing. And for this one, I've got 4x equals 1, so x equals 1, 4. And there's my 3 solutions, 2 on the 0 and 1 on the 1, 4. Give me the 3. Because 12 is not a perfect cube, and x squared is not a perfect cube. Yeah. I multiplied the top and the bottom by the square root of 3. Yes. Charlie Ray, we are going over homework. What should I do first? Tell me what to do first. Okay, then what? Yes. I don't know, can you? What else? Bigger. 3x, right? If I take 3x out, what's left? 27x cubed minus 1. Now, Bella, here's my difference of 2 cubes. You see the difference? This is 3x times 3x times 3x. This is 1 times 1 times 1. So now I can do my difference of 2 cubes. So I can do little parenthesis, big parenthesis, same, change, plus. What times itself 3 times gives you 27x cubed? Bless you. 3x. What times itself 3 times gives you 1? 1. Square the first. Put them together. square the last. Now everybody goes to 0. This one's hard because anytime you have a sum or difference of cubes, I'm going to end up using quadratic formula. It always works like that. So here, if 3x equals 0, that means x equals 0. There's one solution. How many solutions should I be getting? 4. How do you know? The exponent, biggest exponent, the degree. That's right. No, what happens is when you do, y'all, be quiet, stop. When you do quadratic formula, you get 2 answers. So there's 2, and then the quadratic formula will give me the remaining 2. So x equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. And now we just clean it up. Negative 3 plus or minus the square root of 9 minus 36. Bless you. What's 9 minus 36? Negative 27. Can you take anything out of negative 27? Any perfect square? You do have to make it an I. 9. That's exactly right. So this square root of negative 27, if I take the I out, and then the 9 times 3, I end up with 3I root 3. Right? Nine times 3 is 27. Now I can divide everybody by 3. Be careful when you do this because you can't divide what's under the radical. But as long as you can divide the number in front of the radical, and the number here by something, you can simplify it that way. So I can divide these all by 3, and that would give me negative 1 plus or minus I root 3. Don't bother that radical. You can't simplify with that over 6. What else on your homework? 12. Why is 12 so bad? 12? Do I not have the right sheet? Is number 12? My number 12 says 2x to the 6th. I remember talking about this one yet. But the front of my sheet is right. What in the world is going
You don't know what
on?
you're doing.
Yeah, but clearly the front was right. Oh, I got it. Yeah, but how is the front? The front's right, but the printer picked up the wrong one for the back. Okay. Okay, the population of a species is modeled by.
Oh my goodness, no. Oh my goodness.
No, it didn't spill much.
If I slip and fall, can I see?
It's back here by me. Oh my gosh. I don't need anything, Logan. It's all good. The population. No, this is the one I. Get up. Get up.
She's stepping on my hand. I can't
play baseball. Logan, 1.
Extra tough.
All right, this is the one I walked you through yesterday before you left, but I don't think some of y'all listened to me. If this gives you the population and it says find the number of years until the species is extinct, what's the population when something's extinct? 0. So all it's doing is saying solve that. So you just do it like a normal problem and find t. You get two different answers, but when you do, one of them is negative, right? One should be negative and one positive? Yes or no? Maybe so. Right, so that doesn't make sense. Okay, let's do it. Let's do it. Let's do it. I'm actually going to move everything to the other side so that my leading coefficient is positive. So I'm going to make it t to the fourth minus 72t squared minus 225. Y'all with me so far? Oh, well, I guess you get 4. One of them might be a bounce, though. 2 of them might be a bounce. We'll see. Let's see what happens. This is quadratic form, even, half, constant. So what multiplies to negative 225 t to the fourth but adds to 72? 75 and 3. So negative 75 and 3. So let's just plug it in and see what happens. Slash, what can I take out of the first two? Whoa, t squared, which will leave me t squared minus 75. 3 times t squared minus, what's 2, what is it? Now let's think about this conceptually as we solve this, right? If I've got t squared minus 75 equals 0 and t squared plus 3 equals 0. T squared equals negative 3. If I do this, if I'm thinking about number of years until they're extinct, that answer makes no sense, right?
No, absolutely.
You can't have, what, I times the square root of 3 years. So I'm going to eliminate that answer from my choices because it just doesn't make sense in context of the problem. So now let's focus on the other side. T squared minus 75 equals 0. So t squared equals 75, and then I take the square root, 25 and 3. So plus or minus 5, yeah. I moved everything the very first step. I moved everything and made my first number positive. You don't have to. It makes it easier to factor. Is what it is. Well, I can't use the negative one, right? Because I'm not going to say, oh, they go extinct in negative 5 square root 3 years. But I could use the positive one.
More. Or one more.
8. Eight doesn't.
Oh, never mind.
You have to make all of them equal 0.
You got everything cancelled. So on the quiz, it can generate like
Why are y'all? Logan?
please show us if
There's some from.
Alright, I'm gonna make it equal 0. And now I look, is it a special pattern? Can I slash it? Does it factor? It does, it factors because I've got even half constant, right? That's what I'm looking for, even half constant. So what multiplies to negative 18x to the fourth but adds to negative 17x squared? Negative 18 and positive 1. What can I take out of the first two? X squared X squared minus 18
Dang it,
is
I
left.
never get these.
1. So I have x squared minus 18, x squared plus 1, and I can't factor either of those any further, so I go ahead and set the pieces to 0. X squared minus 18 equals 0. X squared plus 1 equals 0. That's if it's a perfect square trinomial. You can have perfect square trinomial, sum or difference of cubes, difference of squares. Say again. Yeah. This is just quadratic form. It's not really. It's the same technique you've always used. Which one? 9 and 10. All right, 9 and 10, and then we're gonna go ahead and start. Oh, golly, that scared me. I thought it was
Good golly. Jeez. Great golly, man. That one was a good one. You really.
Quadratic form again. What multiplies to negative 36x to the fourth but adds to 35x squared? Negative 1 and 36. It doesn't matter which one comes when. It's easier if you put your negative first, though. As I slash, I take out an x squared. I'm left with 4x squared minus 1. I take out a 9. I'm left with 4x squared minus 1. This one's a good one because I end up with a difference of 2 squares here in the second one. So I can take that one step further, x squared plus 9. Why can't I do the first one? It's addition, not subtraction. That's exactly right. Addition only works when it's cubes, not when it's squares. All right, everybody to 0.
No, we can't.
Plus or minus 3i. 1/2. Difference of 2
What
squares.
about the coach? What about the coach?
If it didn't say solve, would you stop at like the very last X?
You only solve when there's an equal something. If you don't see an equal sign, you're only factoring. If you see an equal sign, you're going all the way. This is factored. They're both perfect squares with a minus sign in the middle. Both.
But you have not done the difference of squares there, just have plus or minus 1/2.
Yes. But if it said factor completely, you'd have lost points if you didn't do that. So we always factor completely. Because this is not factored completely, this is.
Yeah, but it wasn't.
But if you were solving, it would work.
I didn't break it, I didn't break 4x squared. So like,
But you got plus or minus 1/2.
Yeah, like when I beat
That's okay.
Robinson,
But if it says factor completely, make sure you break down all those parentheses. What else? Anything? 10, and then we're done. 10, x cubed plus 3x squared equals 24x plus 72. I'm going to make it equal 0. I'm going to move these all over. So I have x cubed plus 3x squared minus 24x minus 72. This is quadratic form. I've got, oh, nope, it's not. I'm going to try to slash it. There's 4 terms. I can take an x squared out of the first 2. It leaves me with x plus 3. I can take a negative 24. The middle sign has to stay. Logan.
If you see 4 terms and you like that,
Slash it. Yep, try to slash it. All right, it leaves me with x plus 3 times x squared minus 24, and I'm ready to set my pieces to 0. Negative 3. I can do the square root. 4 and 6. So plus or minus 2 root 3. Parallel a plain old long division problem alongside a polynomial long division problem so that you see that all the steps are exactly the same. But a couple things I need to tell you before we start, because they're crucial in your being able to do polynomial long division. Couple of things. Thing number 1, we use what we call placeholders. They do exactly what they sound like they do. They hold the place of something that's missing. So if I have 5x to the 4th plus 2x to the 3rd minus 7x plus 1, do you see that I'm missing something there? I have to start with the highest degree and have everything down to the constant. Okay, and if anything's missing, I hold the place. Well, what do I hold the place with? I hold the place with a 0. That's exactly right. So the placeholder would be 5x to the 4th plus 2x cubed, 0x squared minus 7x plus 1. So when you hear me say placeholders, this is what I'm talking about. Holding the place of something that's missing. Yeah. Yeah, it'll always be plus. Y'all okay so far? All right. When you're doing regular division, if I have 5 divided by 12, if you set that up in long division form, remember the little house that does like this? What goes outside the house? The 5 or the 12? The 12. What goes inside the 5, right? So this is the outside, this is the inside. I could also write this as 5 divided by 12. And again, this is inside, this is outside. Go with me? Okay, any of those 3 forms. Be able to get it here. And you need a placeholder, if you need a placeholder. All right, y'all, there's nothing to it but to do it. Again, I'm going to run a regular, it's going to take me a long time to do the first one. They do not take this long. It's just because I'm showing you an example as we go along and I'm walking through each and every step. Some people like to start these with colored pencils because it helps you keep up with the steps. Your neatness and organization is going to be what's key here, okay? All right, here we go. I am going to do, let's say, 512 divided by 3 doesn't go into that evenly, does it? Can I do that on the calculator? Okay, good. This is the one that I'm going to use as an example, and then your number 1 on your homework is the one that I'm going to walk through for the polynomial example. So that is x to the 4th plus 3x cubed minus x squared minus x plus 6 over x plus 3. All right, do I need any placeholders anywhere in the polynomial example? No. All right, set up your division. 3 into 512. I'm going to do the same in my polynomial. X plus 3 into x to the 4th plus 3x cubed minus x squared minus x plus 6. Looking at the one on the left, tell me what? It's just an example that I'm using to teach it. Yes. You'll see why. Tell me what the first, if you look at the left, 3 into 5, 12, what is the first step you do? If you're explaining this to someone who has never, ever, ever in their life seen long division, you would say 3 into 5. How many times does 3 go into 5? And you put it up here. Now just wait, because I'm going to come over to my polynomial and I'm going to do the same thing. But I'm only going to look at the first term. How many times does x go into x to the 4th? In other words, what do I need to multiply x by to get x to the 4th? No. X to the 3rd. What do you multiply x by to get x to the 4th? X to the 3rd. Now, be careful because I'm going to kind of keep all my powers lined up here. It will help you. So I'm going to go here to the column where the 3rd power is, and I'm going to put x to the 3rd. Everybody with me? I want to keep my columns, think about it like this. If my columns were like this, anything that has a power of 4, I'm going to put in this first column. Anything with a power of 3 in the second column, and so on. Just helps to keep my work nice, neat, and organized, and that'll help me. All right, back to the purple example on the left, 3 into 5, 12. Once you figure that number out, what do you do? Somebody that's never seen it. What does remainder mean? I don't know what you're talking about. What do? You put the 1. Where's that coming from? Easy. Keep going. Break it down even more. What did you do? What do you do? 1 times 3. Do we all agree? We go, okay, well, 1 times 3 is 3, and we put it right here. Agree or disagree? Y'all remember that? I'm going to do the same thing. I'm going to come over here, and I'm going to say x cubed, but I have to multiply it to everything out here. So what is x cubed times x? X to the 4th. And then what is x cubed times 3? 3x cubed. It's polynomial long division mode. All right, go back to the other side. Once you multiply, what do? You subtract, right? I'm going to subtract here, and I get 2. I'm going to do the same on the polynomial. I'm going to subtract, but look, I have to subtract everything. X to the 4th minus x to the 4th. Well, that cancels. 3x to the 3rd minus 3x to the 3rd. Great day. I would have picked one that's like that. It's just 0, right? So I got 0. 0x cubed. Go back to the left side. What do you do next?
Bring down the 1.
Bring down the 1. I'm going to do the same over here, only it's not 1, it's negative x squared. Now I'm going to ignore this 0 since it's nothing. That's right. What do I multiply x by now? Oh, I'm jumping ahead of myself, sorry. What do you do back over here? The process starts over, right? 3 goes into 21 how many times? And you put it up here. So I'm going to do the same thing. What do I multiply x by to get negative x squared? Negative x. I'm going to again put that in this column over here. What do you multiply x by to get negative x squared? Now, when I multiply around, I get negative x squared minus 3x. Notice I got something here and I don't have a term there. Yeah. I keep everything in the columns that it goes in. You don't have to do that if you put it over there. Because you're negative x times 3. It bumps to both of them. It has to multiply to both. Now notice I got an x here and I didn't have one, so I had to drop down the next term so I had something to subtract it from. This looks terrible when you first see it, but once you get the hang of it, everybody always remembers it for some reason. And I know, and then everybody says, I'll never remember this, I'll never use this, this is stupid. All right, so I've got, the first should always cancel out for you. That should always happen. Negative x minus negative 3x is what? Positive 2x. What do I do now? Drop down the next term and do it all again. What goes up top this time? 2. Why 2? 2 times x is 2x. It's what do I multiply this by to get this? And it's 2. Multiply it around, but when you do, it has to multiply to both pieces. So 2 times x is 2x. 2 times 3 is I can't read it anymore. No, it's a plus 3. Yes. Now, what is this number called if I get a number there? Somebody said it. Remainder. If I came over here and I kept working, this would be my remainder. If you have a remainder, how do you address a remainder without writing R2? Without a decimal. Give me another way. Nobody? Y'all never had a teacher explain this to you? You can always take the number and add to it the remainder over what you divided by. So this answer would be 170 and 2/3. Y'all never learned that. Well, now you did. Now you know. That's the way you can do it. And so if I come back to the polynomial, if that had not been 0, I would do plus whatever that remainder is over what's on the outside. So when I divide these two, I get x to the 3rd minus x plus 2. And since there's no remainder, that's all I do. And I just pulled that, on the sheet. I just pulled that off of the thing. I'll do one more with you since we have about 10 minutes left, and I'll do it as one of your homeworks. We'll do number 2. First thing I'm going to ask is, do I need any placeholders? 4, 3, 2, 1 constant. Number 2. The answer is no. If you need placeholders. All right. Look at the biggest exponent and make sure you have every exponent from there down. What's the first thing that goes up top? Look at the biggest exponent. So 2, 1 constant, I'm good. 4, 3, 2, 1 constant, I'm good. If I was missing any of those, I'd hold the place with a 0. Like if it was just 2x to the 4th minus 5x squared, I would do 2x to the 4th plus 0x cubed minus 5x. so that I had that 3. Yes, so I always look at first terms. So what do I multiply this by to get this? 2x squared. It goes up top, and then I multiply around. But when I multiply around, I multiply to everything outside. So 2x squared times x squared is 2x to the 4th. 2x squared times 4x is 8x to the 3rd. And 2x squared minus 2x and I subtract all of this. Zero. Now we've just gotten lucky with getting 2 zeros to start with both times. Negative 5x squared minus negative 4x squared gives me negative x squared. Drop down the next term. But this one, since I got 2 zeros to start with, I'm going to need to drop down 2 terms because I got 3 pieces outside here. And the process repeats. It's so much repetition that you can't help but remember it because you do it over and over and over. Why do none of these have remainders? What the heck, bro? Say again.
Why did you bring down 4 and 2?
Because this one has 3 pieces, and I know whenever I multiply around, I'm going to get 3 pieces, so I need to have a spot for 3. Yes. Like that. No, you do a plus sign. All right, what do I need up top? Negative 1. Multiply around. Negative x squared minus 4x plus 2. This is garbage. This is 0, so this is my answer. Because that's my remainder. I really wanted to do one that didn't have a remainder. I mean, that did have a remainder. None of these have remainders. That's no bueno. Hold on.